Audio Jungle. Audio Jungle. Audio Jungle.
Hi, I am Yvonne Fernandez.
And I'm Christine Gastupa.
And in today's video, we are going to discuss about the 16 separation techniques.
For today's discussion, we will tackle about the separation techniques, their properties, their examples and applications, and lastly, the conclusion.
Today's objectives are to comprehend and fully understand what separation technique is, as well as the 16 examples of separation techniques, their definitions, properties, when they are appropriate to use, and their examples.
Today, we will start our discussion on following terms: 16 separation techniques, properties, examples, and application.
And now, let us proceed immediately to the discussion.
Separation techniques are those techniques that can be used to separate two different states of matter, such as liquid and solid. Separation process or a separation method, or simply a separation, is a methodology to attain any mass transfer phenomenon that covers a mixture of substances into two or more distinct product mixtures. There are 16 types of separation techniques, which are handpicking, threshing, winnowing, sieving, evaporation, filtration, separating funnel, magnetic separation, simple distillation, fractional distillation, chromatography, sublimation, sedimentation and decantation, centrifuge, dissolution, and crystallization. Now let us discuss them in detail. First is the handpicking process. This method involves simply picking out all the unwanted substances by hand and separating them from useful ones. For example, if we gave you a bucket full of mangoes and apples and asked you to separate them, how would you do it? So, which separation method are you going to use? Simply begin by selecting one type of fruit, such as mango or an apple. You will be able to distinguish one from the other in this manner. Another example is when we buy wheat, rice, and pulses from the market. These food grains usually contain small pieces of stones and insects. These pieces of stone and insects are harmful to us. So we separate the small pieces of stones and insects from wheat, rice, and pulses before using them. Note that conditions for handpicking is that the mixture should contain impurities of a little larger size and different colors. Next is the threshing process. This method is mostly done during the harvesting of crops. Normally, the stalks of the wheat are dried once it is harvested. The grain is then separated from the stalks and grounded into the flour by beating the dry stalks to shake off the dry grains. Threshing is also used for the separation of seeds from the harvested stalks. Winnowing. Winnowing is when the grains are collected from the process of threshing. It needs to be cleared out of the husk and chaffs before it is turned into flour. Normally, the separation of the mixture is carried out with the help of wind or blowing air. The husk and chaff are blown away by the strong wind when the farmers drop the mixture from a certain height to the ground. The heavier grains are collected at one place. An example of winnowing is when wheat is separated from husk by using winnowing method. Wheat and husk mixture is allowed to fall from a height. Husk being lighter than wheat grains get separated from the wheat because of wind or air blow. Dirt particles can be removed from grains by winnowing, and corns are separated from straw by winnowing. The fourth separating technique is sieving or sifting. Sieving or sifting is done to separate mixtures that contain substances mostly of different sizes. The mixture is passed through the pores of the sieve. All the smaller substances pass through easily while the bigger components of the mixture are retained. An example of sift is using a gold mining pan to strain gold from sand, to pass flour through a screen to separate out the lumps, and separating fine gravel from coarse gravel. Evaporation. Evaporation is a technique that is used in separating a mixture, usually a solution of a solvent and a soluble liquid. In this method, the solution is heated until the organic solvent evaporates, where it turns into a gas and mostly leaves behind the solid residue. An example of evaporation is when we iron our clothes. Have you ever noticed that ironing slightly damp clothes works best to get the wrinkles out? This is due to the evaporation of the water in the clothing. It creates a steaming effect, making your damp clothes dry and wrinkle-free. And you might not realize it, but your kettle whistles when your water is boiling due to evaporation. The water starts to evaporate into steam and causes the kettle to whistle, letting you know your water is ready. The sixth separation technique includes filtration process. The most common method of separating a liquid from an insoluble solid is the filtration. Take, for example, the mixture of sand and water. Filtration is used here to remove solid particles from the liquid. Various filtering agents are normally used, like filtering paper or other materials. The sand or mud that stays behind in the filter paper, it becomes the residue, and the water passes through the filter paper, becomes the filtrate. Another example is when you brew coffee. Brewing coffee involves passing hot water to the ground coffee in the filter. The liquid coffee is the filtrate. Next is the separating funnel. Separating funnels use a means to segregate two immiscible liquids. The mechanism involves taking advantage of the unequal density of the particles in the mixture. For example, water and kerosene, petrol and water, oil and water, and etc. can be separated by using separating funnel. And the eighth separation technique includes magnetic separation. When one substance in the mixture has some magnetic properties, then this method is quite useful. Strong magnets are commonly used to separate magnetic elements. The mixture of iron-filling sand and iodine can be very well separated using magnetic separation because, as we know, iron is a magnetic material and will be attracted by magnet. Also, a mixture of iron filling and sulfur powder can be separated by using a magnet. This is because iron filling are attracted by magnet, whereas sulfur is not attracted by a magnet.
Simple distillation. Distillation is a separation technique that takes advantage of the boiling point. Therefore, simple distillation is a method of separating mixtures based on differences in their volatilities in a boiling liquid mixture. It is a method for separating the solvent from a solution. For example, water can be separated from the salt solution by simple distillation. This method works because water has much lower boiling point than salt. When the solution is heated, the water evaporates. It is then cooled and condensed into a separate container. The salt does not evaporate, and so it stays behind. The second example of a simple distillation involving water is a separation of sugar-water blend. Since sugar and water have different boiling points, the water will begin to evaporate first and then cool to turn into a pure water. Sugar will be left behind in the original container. For our next separation technique, we have fractional distillation. Fractional distillation is a type of distillation that involves the separation of miscible liquids. The process involves repeated distillations and condensations, and the mixture is usually separated into component parts. It is a method for separating a liquid from a mixture of two or more liquids. For example, liquid ethanol can be separated from a mixture of ethanol and water by fractional distillation. This method works because the liquids in the mixture have different boiling points. When the mixture is heated, one liquid evaporates before the other. Some examples of fractional distillation in daily life are oil refining, alcohol manufacturing, air separation, and even perfume manufacturing. Now the question is, how do we differentiate simple distillation from fractional distillation? Simple distillation is a method used to separate substances and mixtures with significantly different boiling points, while fractional distillation is used for mixtures containing chemicals with boiling points close to each other. Chromatography. Chromatography is based on the principle where molecules in a mixture are applied onto the surface or into the solid, and the fluid's stationary phase or the stable phase is separating from each other while moving with the aid of a mobile phase. So chromatography is a process for separating components of a mixture. There are actually different types of chromatography, which include liquid, paper, gas, ion exchange, column, and many more. The two main types of chromatography are liquid chromatography, LC, and gas chromatography, GC. Basically, chromatography is a technique for separating based on physical or chemical properties. We have colored ink, for example. Colored ink components have different degrees of solubility in water, ethanol, or propanol. When a filter paper with a spot of ink is put in ethanol, the color pigments spread out, covering different distances from the spot. The line where the ink spot is put is the baseline, while the line through the furthest point the solvent reaches is the solvent front. The filter paper is the stationary phase, while ethanol is the mobile phase. Another example is when amino acids dissolve in phenol to form colored products. When a spot of the mixture is put on chromatography paper and then dipped in phenol, the amino acids form different colored products with different degrees of solubility. Our next separation technique is sublimation. Sublimation is the separation technique where a substance makes a transition from the solid to the gas state directly. The substance does not undergo the liquid stage, therefore it is used to illustrate a solid to gas transition between the states of a substance. For the application of sublimation, we have water. Snow tends to sublime in case of extreme low temperatures and dry winds. Extreme temperatures causes the snow to vaporize before it undergoes the melting procedure. Another example is dry ice. Dry ice is the solid form of carbon dioxide, which is most commonly used in ice cream parlors. The substance is safe to handle and creates a smoky effect, and when we submerge this compound in water as a solvent, the bubbles emerge due to the emission of heat to create smoke. This causes the sublimation of dry ice. Next are sedimentation and decantation. Sedimentation is the process of settling down the heavier particles present in a liquid mixture. It is defined as the separation process in which insoluble impurities are separated from the solution. Meanwhile, decantation is the process of separating liquid components of a mixture while the solid component has settled at the bottom as sediments. The basic principle of decantation is that heavier or the denser substances sink, while the lighter or the less dense substances float. Sedimentation and decantation methods are used for the separation of insoluble substances which are heavier than liquid. For example, in a mixture of sand and water, sand settles down at the bottom. This is sedimentation. When water is separated from the mixture of sand and water, it is decantation. Some mixtures that can use decantation to separate mixtures are oil and water. Oil floats on top of the water after letting a mixture of oil and water sit. The oil can be poured off of the water. In a separatory funnel, the water can be drained away from the oil. Our next separation technique is centrifuge. Centrifugation separates the components of heterogeneous mixtures. This includes liquids and liquids, solids and liquids, and solids and liquids and gases. Centrifugation uses centrifugal force to move dense components to the outside of the container. This causes the solid to settle more rapidly and completely. Under the influence of gravitational force, substances separate according to their density. Some common examples of centrifugation includes the extraction of fat from milk in order to produce skim milk, the removal of water from moist lettuce with the help of a salad spinner, and lastly, the spin drying of water in washing machines in order to remove water from the clothing. The next separation technique is dissolution. The dissolution process is a process by which the molecules of a substance called solute disperse within another substance called solvent to give a homogeneous mixture called solution, in which each solute molecule is completed surrounded by solvent molecules. For example, we have a mixture of soluble, which is salt, and insoluble solid, which is sand, that can be separated by using an appropriate solvent, which is water. The one that is not dissolved in the chosen solvent can be removed by filtration. For our last one, we have crystallization. It is a method to separate a soluble solid from its solution based on a different solubility of solid in water at 25 degrees Celsius. Generally, the solubility of most solids is directly proportional to the temperature. Therefore, when it cools, the solubility will decrease and the excess solid will crystallize. An excellent and a well-known example of separation based on crystallization is the formation of ice in seawater. An average 1 kg of seawater contains 965 grams of water and 35 grams of dissolved salts. Another example is salt crystallization, which is the most practical use of crystallization and the most cost-effective technique to create salt today. To summarize everything we have covered, a separation process is a method that converts a mixture or solution of chemical substances into two or more distinct product mixtures. In other words, it is a scientific process of separating two or more substances in order to achieve purity. We have discussed 16 separation techniques, and there are many other types of separation techniques that we use on a daily basis but rarely notice, such as filtering, centrifuging, decanting, fractional distillation, sieving, and many others. Each of these methods has a specific application in our daily lives that makes our tasks much easier to complete. To carry out any separation technique properly, we must first understand how to use it. And with that, we hope that we have instilled knowledge about separation techniques, their type, definition, properties, and applications in our daily lives. Thank you for watching, and we'll see you next time.
Audio Jungle. Audio Jungle. Audio Jungle.